Good morning, everybody. This is just the basic electrical practical aspects for water heaters. The course, it's an introduction overview for the complete course curriculum to tell you what is entitled in the course and what you're about to learn. Just the tips to continue to prevent COVID-19. Always wear a mask when out in public, wash your hands with soap, alcohol-based hand sanitizer, avoid touching your eyes. Cover your cough or sneeze in a flexed elbow or tissue, then throw the tissue in the bin, and then clean and disinfect frequently to stay safe. Okay, the benefits for you as a professional plumber completing this course. Electricity is dangerous and always present to various types of water heater installations. You as plumber will directly be exposed to this dangers of electricity and when conducting maintenance work. The immediate benefits making you aware of the safety aspects, and this is really the whole crux of the course is for the safety of it and to work effectively. Enhance your experience and credibility, safe legal actions for your company through conducting professional work, obtain credible knowledge for you and your company co-workers, learn the new approaches for safety aspects, improve your company future prospects, create a trusted environment and add value approach with your clients. Approach of this training course, we're not attempting to make the plumbers electricians. But like I said before, the plumbers are exposed to electrical installations, especially when it comes to geyser replacements, geyser maintenance. But to skill the plumbers with more general knowledge directly related to the profession. Rather, adopt the formative awareness approach. We want to create a safety aspect for plumbers to mitigate risks involved, awareness for clients and water heaters, installation non-compliance. So, the course curriculum, an overview consists of 5 courses. The first one, basic fundamentals. We just want to introduce you to the basic fundamentals of electricity. Then test instruments, that's the most important thing, how to test to make sure it's safe to work. Basic of electrical supplies for water heaters, what type of supplies. Then the electrical safety in the work environment, what to look out for, what to do. Locking out the system to work safe. And then the main aspect, the earthing and bonding for water heater systems, which is of importance. The curriculum detail, in short, we've got the 5 courses, like I've mentioned. Every course consists of learning activities. Course 1 will consist of 6 learning activities. Course 2 of 3 learning activities. Course 3 of 2. Course 4 of 2 learning activities, and course 5 of learning activities. The learning activity content you will see on the right-hand side there. That is all the different content we're addressing in this course to make you more aware of the electrical installations, regulations, the OSH Act. How does power work? What is Ohm's law? Kilowatt usage? How does a circuit breaker work? What is the earth leakage device? Basic fundamentals of that. Then course 2, the digital multimeters and measurements, how to use a multimeter, how to use a clamp tester. The course options and prerequisites. Option 1, you can purchase the complete course containing all 5 courses and receive discount. Should you have none or limited knowledge on basic fundamentals of electricity, you should purchase the complete course. That is just a must to have the basic knowledge. This option will be beneficial to learn the full understanding of all basic fundamentals for earthing and bonding and obtaining a broader knowledge foundation. You'll be developing competence in better understanding basic fundamentals. That's all in option 1 if you purchase the complete course. Option 2, you purchase each course separate of your choice of the complete course. Course 1 and 2 are basic fundamentals, basically, of electricity. Please note that you should only purchase separate courses. You must have a full knowledge understanding of basic fundamentals of electricity and test instruments contained in course 1 and 2. This is a prerequisite for courses 3, 4, and 5. Should you have none or limited knowledge, you can purchase the complete course. You will experience a positive knowledge enhancement, which you can only apply in your profession as a plumber. This course contributes positively to your business in applying this knowledge. The course pricing structure, we've got the courses outlined there. Course 1 is basic fundamentals at $4.99. Course 2, the prices are there. You can see that the safety in the workplace, and as I said, the complete course will be at a cost of 2,800 Rand, which is really not a high price for all the knowledge and gain you will get out this course. If you've got a money saving tip, I've got it in there. If you purchase all individual courses, the total value will be 3,377 instead of 2,800 Rand. So you can actually see that you're going to get 17% discount if you complete the whole course and purchase the whole course. Okay, let's look at basic fundamentals of electricity. I've just took some slides out of the courses material just to show you what is the content. We've got Ohm's law, voltage. That's really the basic for you to understand what is resistance, what is amperes, leakage flow current. That's very important because that comes to bonding principles. What is power? The kilowatt hour usage for the geyser element, for example. Electromagnetic induction that we discuss regarding the circuit breaker operations and the earth leakage devices. I've got basic calculations in that course how to calculate the resistance, the voltage, and the amperes of a certain pure resistive load, for instance, a geyser element, so you can quickly determine what is faulty. I've got geyser element construction in there, and this is to enable you to understand the leakage current, which we discuss in this module. Definition of leakage current flow. You'll often get to a site where the client says the earth leakage is stripping, and the geyser is obviously the cause, and that comes down to leakage current flow inside the geyser element. And in this course, I also explain to you how does it occur, what is the definition of leakage current flow, and obviously then the shortest route path flow down to earth. So that's basically on the leakage current flow, basic calculations when it comes to wattage. We all know the elements are rated in watts. Here I will show you how to do the power calculation. If you've got the wattage, how to determine the resistance of the element, so you can actually measure the element and determine if it's faulty or not, or if it's acceptable range of resistance. If you've got the resistance and the power, how to calculate the current. All these formulas are more detailed explained in the course. I've got the electromagnetic induction. If a current passes through a copper coil or wire inside, the steel core becomes magnetic. And this principle is very important for you to understand the basic operation of an earth leakage device, because there's a few people that actually understand how earth leakage works. And once you understand the electromagnetic principles, it will make your life much easier in a maintenance or a repair situation. I've got circuit breaker construction in there. Basic, how does a circuit breaker work? What is inside the circuit breaker? How to connect it? And this will also enhance your knowledge during maintenance activities in a water heater system. I've got specifications of an earth leakage circuit breaker in there. What is touch voltage? Often, and this comes back to bonding. The client will tell you, when I touch the shower taps or the taps in the kitchen, I get a little tingling in my hands. That is leakage current. So actually, there is not correct bonding done, and there's a leakage current inside the element. And this will explain to you what is leakage current, how does the earth leakage pick it up, and what's the maximum allowable leakage current to flow through any circuit to make it safe for human beings. And I also address the leakage currents which the human body can actually take before it gets electrocuted. So the prerequisites for course 1, basic fundamentals. Before we start with course 2, there's no prerequisite for course 1. That's your basics, your starting course. But the prerequisite for course 2 will be course 1. Let's have a look at course 2, basic fundamentals of test instruments. We will discuss digital multimeters and measurements, cam testers, and I actually give you practical demonstrations in the training material how to test voltage, because this is important. The biggest aspect regarding the testing instruments is people getting electrocuted unnecessarily because they don't test, they accept the power is off by just switching the appliance off or the main switchboard, and this is not correct way of doing it. So this module 2 or course 2 will actually teach you how to use measure instruments. I've got the multimeter in there. It's a diagnostic tool for technicians. I explained to you digital multimeters. How does it work? How to select the correct scale? Where to plug your wires in? So I really give detail there to use the thing correctly and safely. Then we've got safety categories, info multimeters and test instruments. What for you? This will enable you to get more info on to buy a proper multimeter that's correct for your application. We always buy the cheapest ones, and they're not always the correct ones, the legally acceptable ones. So yeah, I explained the category specifications for measurement instruments. I go to insulation resistance testing. I explained to you how to test the geyser element if it's really faulty, if it's got a leakage on it, how to use the insulation resistance tester, and to determine if the element is actually faulty or there could be a circuit fault towards the appliance. Prerequisites for course 3 then will be obviously, once I said again, course 1 basic fundamentals and course 2 basic fundamentals of electricity test instruments. That is your basic fundamentals, your basic knowledge you must gain before you will easily understand course 3, 4, and 5. If we look at course 3 in a summary, here I start with actually focusing on the water heaters. And like I said before, we don't want to make the plumbers electricians. This is a knowledge-based course for you to enhance your basic knowledge and to work safely. That is the main important, and it's beneficial for you as a plumber and for the client. We're looking at the basic supplies and circuit diagram and the wiring methods, isolators, wiring connections, and terminations. In this course 3, I will show you a typically single-phase geyser insulation circuit. I think you all know how that looks, but I'll go into detail what's a circuit breaker, the type of wiring used. People use different types of wiring to supply these geysers with surfexes, twin flattened earth, general purpose wire with conduit. I discuss all these methods and obviously the isolator switches. I look at current ratings for general purpose wire sizes for geysers. So if you can just look at this installation to determine if the wire size is actually correct, and you will not put too much current onto this wire for a particular installation. And the result of that will be that you're going to burn the wires, you create a fire risk to the installation. I'm looking at single-phase isolator switches. Now this topic is a very, very important topic because like you all know, there is isolators at water heaters, and often technicians go and they just switch the isolator off and they do not test. The isolators has been breached out. They might not work because they sit there in the roof for 25 years. They've never switched. And now you come there to do maintenance. You switch it and it doesn't work. We find that often, and this causes a lot of electrocution hazards. So it's important to test it and to understand how does it work. I'll also go to the wiring regulations of where must the isolator be installed on a water heater, what is it supposed to do, and how to lock it out or to switch it off to work safely. We're looking at wiring terminations, what's the correct type or method to join wires. Can we solder it? Can we use proper connectors? I address acceptable connectors in the industry, such as proper clamp connectors. I use screw type connectors, the chock blocks like we all know it, and how to crimp lugs and fiddles, how to terminate these wires correctly. Often we will see 99% of the time people haven't got the proper crimping tool to terminate the wires, and they just use a pliers or a side cutter, and that will definitely create a loose connection over time and create fire hazards. Like you've seen on that slide there was a loose connection. I've got some pictures in here, and what type of wiring, like I said, the surface around metal stiffened cable, your twin flattened earth, or your conduit with your normal wires in. And I also address open wiring systems improves. Where would you find this in very, very old installations, pre-1970? All the old houses has all got this open wire in the ceilings, and this is a huge, huge safety risk. We do address that safety in the workplace as well. If we look at course 4, electrical safety in the workplace. Now, ladies and gentlemen, we often hear that people get electrocuted, especially plumbers, or there was an incident or an accident. Some of them are fatal, others are not fatal. And this comes back down to basics. Most of these accidents happen people are too much in a hurry. They accept the isolator in the geyser installation inside the roof, that it's actually isolating the circuit, and it's not, because that's why, hence the reason you must test and make sure it's safe to work. I address the electrical installation regulations, which is the wiring regulations of South Africa, SANS 10142 Part 1 for residential or wiring of premises. And then we take a quick look at the Occupational Health and Safety Act. What does that say about electrical installations? I'm also looking at voltage drop. I'm explaining to you what is voltage drop, what is allowed, what causes voltage drop. Typically, cable size is not correctly, the circuit is too long. You might find the client will give you a call out, and the problem you experience is the water doesn't get hot that much like it should. Voltage drop could be one of the causes. If the circuit is too far from the main board to the geyser, you get a huge voltage drop if the wires are not selected correctly, and your element doesn't get the appropriate voltage, what it's designed for, to have an output of, example, 3000 watt. It might put out 2000 watt, and hence the water won't heat up properly like it should. So voltage drop causes is specified, how to determine it, what to look out for. I've also got a table in there from the wiring regulations on the maximum length of circuits, on the size wire on the left-hand side column versus the circuit breaker rating. So this is easy for you to determine. If the geyser is supplied by a 20 amp single phase circuit breaker, you look at the wire and you determine that's a 2.5 wire. The maximum length of this circuit should be 33 meters. So if the meter is, if the geyser is situated, for example, 60 meters away from the DB board, with a 2.5 wire and a 20 amp breaker, it's not legal, and hence you'll get a huge voltage drop. With voltage drops problems comes other problems like loose connections, wires gets hot, and that creates fire risks and damage to the installation and to property. We're also looking at the earth wiring, maximum nominal cross-section of the copper earth continuity conductors. On the maximum amperage of the geyser circuit breaker, let's say it's a 20 amp, we've got a 2.5 millimeter wire in for the bonding and the earthing. The maximum distance that circuit could be is 101 meters. So this is a quick table for you to determine, is the installation looking okay or not? If it's not, obviously, you will then inform the client and add that value add service to the client and say, sir, we've picked this up. We're not too sure if it's correct, but it doesn't look correct. So we advise the client to get an accredited electrician to site to investigate it further. So that's why I put this stuff in, so you guys get that extra knowledge to determine if the situation is legal or not. If you're in doubt, you will simply carry that over to the client and inform him to get a qualified electrician out. Then we're looking at the bonding part of the geyser. That will come also in course 5. But yeah, there's a lot of repetitive things in those courses. And from course 1 to 5, I repeat a lot of things because it's so important, especially the bonding conductors. What to use, what's the minimum size of wire, how to do the bonding conductors. I give you a practical demonstration in course 5 I've actually built a little model there to show you what is the correct way of bonding and terminating the bonding conductors onto the copper pipes, because that's where the high impedance or loose connections comes, and then the bonding actually means nothing. So how to use the bonding conductor, how to test it, and what's the maximum resistance of the bonding conductor towards in accordance with SANS 10142. We also address the methods of bonding, what type of wires to use, and the connection methods, the terminations, like I said before, the lugs and that kind of stuff. I've got the OSH Act in there. We actually address the definition of a certificate of compliance for the electrical installation. So you could understand that as well and carry that over to your client, because the client might ask you, what's a COC that I have to get an electrician now? So you can just give him the basic concept and the law requirements around the COC, so he can also understand better. And ladies and gentlemen, by doing these things for your client, you're adding value to them. and for yourself to work, to do your work more professionally in that manner. If we look at the next slide, electrical testing for voltage present, I should actually show you how to test onto the geyser, how to test if there's voltage after you've isolated the geyser for maintenance. Make sure how to do it properly. We all know water heaters are installed, most of them in seating voids or up in the roof where there's a restricted confined space. Should you get electrocuted there, it's not a nice place to get, because you're cramped up, you're sitting in there, there's not space, it could become fatal. So test is the most important thing, how to do it correctly and how to do it safely. Also, I explained to you how to test your meter, because a lot of people take the meter out of the toolbox, go switch it on, test, and after they've switched the power off, and that's not correct. You first test your meter with power on, and then switch the power off and test again. Then you've tested your electrical test instrument that it's actually functioning correctly before you isolate. Then you can trust the instrument, because that instrument is your lifeline. You're trusting the instrument that it tells you there's no voltage present, and you touch that bare wires to loosen the wires on the element, for example, to change the element on the thermostat. So testing the meter is of utmost important, and very few people actually does it correctly. I also address isolation equipment, how to lock out circuit breakers. If there's no lockout means, what else to do, to put somebody there to switch the main power off, to put a person at the DB while you're up in the roof to ensure that nobody switches the power on. We're looking at the work environment. Inside your work environment, especially in the roof spaces, you'll see there's photos of open wiring. You will find open junction boxes or termination connection boxes in roofs, which can be very dangerous because wires could be open against the regulations and there's live power there, and that could be fatal. So we've addressed all that safety aspects in this course 4. Course 5 is the crux of the whole course, earthing and bonding for water heaters. We've addressed the earthing, geyser, bonding, water pipes, and then the electrical installation COC. Just to show you once again in a little bit more in detail what we've discussed before of the COC, the regulations, we're actually looking at the COC, just for you to understand it a bit better. We're looking at the earthing of the geyser, your normal earthing. On the picture there, all that class 1 appliances provided for earth terminals. Some water heaters, you will find the neutral is wired through the thermostat, which is not according to the regulation. The regulation clearly stipulates that only live wires must be switched through a switch. In this picture I've got here, you've got the neutral through the, and when you do the basic fundamentals, you'll understand when is a neutral live and when is a live wire live. A live wire is basically always live. A neutral only becomes live wire with current carrying capacity once there is a load connected. So if a geyser element is on, you will have the same effect on the neutral wire regarding current and voltage as in the live wire. That's why it's important to switch the correct wire. We've also addressed what must be bonded, how to bond it. All water heaters must be on earth leakage protection. That's a regulation. A simple check to do, you can test up in the geyser, you can trip the client's earth leakage in the DB board by pushing the test button, and then check if the geyser still got power or not. If it's got power, you need to inform the client, so your water heater is not wired according to regulation. Please get a accredited electrician out. So this is all basic general knowledge for you as a plumbing professional to gain that knowledge and to enhance your business. Earthing wires of bonding connectors. I've got a nice drawing there that I actually show you. Your hot and cold water pipe must be bonded together. The earth stud or terminal onto the geyser body itself must be bonded, and that must go to your distribution board with a minimum of 2.5 millimeter square earth wire. Often you will find people use Surfex wire, the round metal stiffening wire, to wire the geysers, and they use that earth for bonding, and that's not correct. In a 2.5 millimeter Surfex, the actual earth wire is 1.5 millimeter. So that's also not according to the regulations. We're looking at earthing and bonding of roof structures. You as plumber might change the gutters on a house or a installation building. If there's bonding present, I address that as well, how to put the bonding back once again, and what must be bonded and what's not allowed to be bonded, or don't have to be bonded, not allowed to, but not in such. What is the electrical regulation stipulates on roof structures and downpipes, when need to bond it and not to bond it. I also address the downpipes, the waste pipes for the wash basins, bathtubs. With the very old houses, the waste pipes are still steel, galvanized steel. And should the power supply comes to the roof of the house, which you'll find in the old areas, you have to bond these waste pipes as well as your gutters. We're looking at the electrical installation certificate, the COC. There you can just get an idea of all the tests that needs to be conducted in a COC. And the first one there, that's the important one, the continuity of bonding for your geyser, which stipulates 0.2 ohm and how to test it. You must test the continuity of the bonding conductor with a insulation resistance tester and not a normal multimeter. That clearly is stipulated by the regulations. Here we look at what type of bolts and nuts to use for the bonding straps. You have to use copper, not galvanized steel or gutter bolts like we know it, because there's a chemical reaction between the galvanizing and the copper. So we need to use the correct materials, and I address this quite a lot in the training material as well. So there's conclusions and questions. Awareness of the plumber installing, earthing and bonding. Like I said before, we're addressing it again. We don't want to make you plumbers electricians, but rather uplift skills and professionalism. Don't leave the installation non-compliant without informing verbally and in writing. If you remove the bonding, do install it again. It's better than just leave it out and inform. Become a lifelong learner through skills education. We want to improve your general knowledge and skills. We want you to adapt a safety approach to your work, because one electrocution of a certain technician, plumber, is one too many. That's what we say. Add value to your. Inform the client always of electrical non-compliance. If you see it, I know you're not a qualified electrician, but if you see something that doesn't look right, it probably isn't right. So just inform the client. Tell him, do your part and say, listen here, sir, please get a qualified electrician out. Ensure that the client understands electrical non-compliance. And contribute to a safer environment. We say conduct more professionalism to inform and do rather than keeping quiet. And I mean, that is the quote I've got there. The trouble is that once you see it, you can't unsee it. So that is the problem. So keeping quiet is not an option. I think it's really beneficial for all parties to inform. So we just don't want to sit around and wait for other people. We just make and we do it. So that's my motto in life. Actions speak louder than words. I hope you've enjoyed this session, and there's a few questions after each course that you must complete. You can also obtain CPD points, and I thank you for watching this webinar. I hope I've clarified some of your questions, but yeah, we want a meaningful experience and awareness training that will contribute to you as professional plumbers. And the main focus is here to perform safer and professional work. The safety aspect, I cannot enhance that in a better way than doing it this way. Thank you, everybody. I hope you enjoyed